Okay, so we are often asked for a simple example of a workflow where Epidonate works as the backend for a data exchange with a participant in the study. So this is a participant that contributes with data, that does not contribute data, so removes data, or manages that data with the read-write construct covered elsewhere. So how does this exchange between the backend and a specific user looks like? So there's a small library called sync_donate we wrote for this purpose, which is a simplification. That's the purpose of this library ultimately, to simplify this get-post exchange. So sync from synchronization with the user-specific backend, so a JSON object. So this is the purpose. So assembly of applications. Web applications are dereferenced from a URL, so nothing new here. And this URL is sometimes composed with parameters. And it's this mechanism of composing the URL with the parameters. And the two parameters we need is the deployment URL, the Epidonate deployment URL, and the user token. So these are the necessary parameters we need. So donate token and deployment URL. You can get the sync library by just calling it directly. So this is an ES6 module, so you can insert it anywhere in the code of your application. And this will automatically harvest from this composition, will harvest the parameters. Sometimes this is a bit confusing for those who have written applications with this emphasis on personalizing its use. And so we'll spend a little time discussing the difference between a search and a hash parameterization of a domain or an application URL. So let you read this. We'll have an example at the end that covers the discussions described here. So let's move to that, and this of course is the video recorded and made available at the end of the page. So I'm going to start with a simple questionnaire application. Let's refresh it, make sure nothing is there. Everything is clear, very good. So open the DevTools. I'm going to start by answering questions. So the developer of this application, Daniel Russ, so that is danielruss.github.io, and this is the application, relies on an internal object called fakeDB to maintain the answer to the questions. And you see it's an empty object, nothing was filled just yet. So how do you feel today? First question, I could say I felt better. And now you could open fakeDB and find out what's inside. So next, what's the problem? So the problem is that I have some fever. It's not true, just an example. Next, and what is my temperature? Is 100 degrees. Next, so let's revisit fakeDB, and you see this information is there now. So what I'm going to do now is I'm going to call the sync library. You typically do this right at the beginning of when the application loads. So the application does not need to keep this visible, right? So that's what this library does immediately. You see how it cleaned it? So I'm going to go back to the application. So you see this slowly. So reload. Refresh. And the first thing you do is load the synchronization library. Now notice on top something is going to happen. The parameters that are specific to this application are going to be removed. And I chose to put those parameters under the hash, and there are some other parameters under the search. So let's look at this before loading. So location, search. I have this lala 1, 2, 3, lele 4, 5, 6. So there they are. And then under the hash, we have the donate token and the donate deployment URL. But you also have Lily 789. So when we load the synchronization library, these two parameters are going to be removed from the hash. If they were provided in the search, they'll just not be removed. And there may be some use cases where you want that to be the case. But today we'll stick with the more common one, which is you want to hide these parameters. So a person got a link by email or some other secure method, and these parameters are extracted. So the user doesn't even see them. So here we go. So they never show up. You just have the la both in the hash and the search that are left. And now we have a sync command. So a single command you can use to both retrieve the content of that specific user's data and retrieve or provide. So with no input arguments, it retrieves the existing. If it has an input argument, it retrieves the existing one, provides the new one, and you have access to both in case you need to compare them. This is discussed here. So current data, I'll have to fix this. So await sync, nothing, as an input argument, retrieves the current data. Otherwise, with the new data, you still get the old data, so the current data. Before you make the call, this will be the same. And then the new data is put in its place. Alright, so with this in mind. So, if I'm syncing something here, it will go straight to this record. But I don't have anything to provide yet. So let's continue the answer of the questionnaire. So we go, how do you feel today? I felt better. Let's choose to have fever and say 100 degrees. So the developer of the application is keeping a structured variable with the answers to these different questions. Not just going forward, but going backwards and changing things, correcting and so on. So if I go to that object, which in this application is called fakeDB, this is entirely up to the application developer where they keep it. So you see here the answers being kept. So ideally, I would make this persistent by donating the data as a user answering the questionnaire. So we will go to sync. First I'm going to provide with no input arguments. Let's see what's there. Nothing. There is an object called call1. And I'm going to provide the new data, so fakeDB. So call1 is the information that was there, and this file here with the responses should be now in the same location. So if I go there and I just ask for the existing record, you find out it's the exact questionnaire. So there's a 100 degrees temperature and the remaining questions here. I don't feel so good was the second option, and so on. So I hope this made it clear what workflow is. So you have a little library called sync that will synchronize an object of your choosing, where you keep the state of the application where the user is providing or managing data. With that library, you can store that object with the structured, that is the structured variable with the responses to the questionnaire in this case, and then you can retrieve it later on. So anytime you can get this data and resume the answer the questionnaire. So here you're recalling an object that is stored in the Epidonate backend. So it's not stored in local storage, it's not stored in this machine specifically. It's stored in a remote location that can only be accessed by this combination of a user token and a deployment URL. So let's show that it is indeed the case that we have data for a specific user committed with persistence in the Epidonate backend. So just open an incognito page, so nothing cached anywhere, providing just the bare information, the application name, a bunch of parameters I'm not going to use for anything, and then the two parameters that we need to rebuild that connection between a specific user answering this questionnaire. So user can jump from one computer to another, and by calling the URL with this composition would retrieve the last available status of the questionnaire. So let's do it. Open the DevTools. At the beginning of the application, the developer would include the sync command. So let's go there. Let's copy it. We are back now to the incognito application. So nothing available in storage, no local storage, no IndexedDB. And By calling this library at the beginning of the application, the credentials disappear, so the user never exposes the credentials when the application loads. They are removed from the hash. And now we should be able to ask the question, sync, what is there? Let's see if my 100-degree temperature is still available. And yes, it is. So you can jump from one machine to the other. The personalized connection is one between the token at Epidonate backend and the application. All right, and I think that concludes the demonstration. Thank you. Bye now.